Hi there, welcome to Mr. Lehan Teaches You Stuff. This is grade 9 chemistry lesson 1, matter and the particle theory. So first thing we want to look at is what is matter? And matter is anything that contains both mass and volume. So we might as well define those as well. Mass is how much matter is in an object. We measure mass in grams, kilograms, milligrams, stuff like that. It's very important that we don't get mass confused with weight. So you may weigh 100 pounds, and when you go into space, let's say, you don't weigh 100 pounds. You're floating around weightless, but you're not floating around massless. You still are made up of the same amount of matter. Similarly, if you step on a scale on the moon, it'll say that you weigh less, right? Because you're not pushing down as hard on that scale because gravity's not as hard or not as strong, but you will not have less mass. You'll have the same amount of mass. Volume is how much space something takes up. We measure volume in liters and milliliters, etc. So the three states of matter are solid, like this rock, liquid, like a glass of water, and gas, like the gas inside this balloon, or possibly the gas in the air that balloon is floating through. There are several changes in state. So melting is when something goes from a solid to a liquid. So there's an example of some ice cubes melting. Freezing is when a liquid turns into a solid, like this water that I left in the freezer. And it's important to note that the melting point is the same as the freezing point. So for water, for example, that's 0 degrees Celsius. So the same temperature at which something melts is the same one at which it will start to freeze. Evaporation is when something goes from a liquid to a gas. So when you've got water boiling on the stove, some of that water will evaporate. Condensation is when something goes from a gas to a liquid. If you ever get a cold pop, for example, out of the fridge, you might notice that there's condensation around it. Now for two that you may not have heard of, sublimation and deposition. Sublimation is when something goes from a solid to a gas. So an example of that would be dry ice, which is basically solid carbon dioxide. It changes directly into a gas. And deposition, gas to a solid. This is more common than you might think. That's what frost is. So if you ever see frost on pine branch like this, or frost on a window, that is solid water that has just come out of the air. It went directly from gaseous water to solid water. Now, how does this all relate to the particle? The particle theory was created to describe the structure and behavior of matter, and there's 5 main points to the particle theory, so we'll take a look at those. First point is that all matter is made up of tiny particles. And all of those particles have spaces in between them. So there's a little bit of room between each one of those particles. Point number 3, all particles of one pure substance are the same. Different substances are made of different particles. So if we've got 2 substances here, they're both pure substances. They're all made of the same type of particle. But since they're different types of substances, they have different types of particles making them up. One, in this case, is green and one is blue. Number 4, the particles are always moving. The more energy the particles have, the faster they move. So even for a solid object, so the computer you're watching this on, your hand, your desk, all the particles that make up that desk or hand or computer are moving a little bit. To the extent to which they move around determines whether a solid, a liquid, or a gas, but they're all moving a little bit. And there are attractive forces between the particles. These forces are stronger when the particles are closer together. So the 3 particles here, they're fairly close together. They're very attracted to each other, whereas this one off by itself at the bottom is not as attracted to the other ones. So how does the particle theory relate to the states of matter? As energy is added to particles, they move around more. This causes the bonds between the particles to weaken. So here we have some very low energy particles. This is a solid. Now, if this solid is at absolute zero, then it's not going to be moving around at all. But as we add a little bit of energy to it, a little bit of heat, those particles will start to jiggle around more. So it's still a solid. None of the particles are moving past each other, but they'll kind of shake in place. Now, when you add even more energy, the particles get so much energy that they move past each other. So if they can slide past each other and move around, that substance is now a liquid. Then as you add even more energy, the particles are no longer bonded to each other. So they're flying around randomly. The substance is now a gas. These are very high energy particles. You can tell by the looks on their faces. Now, evaporation is when something turns from a liquid to a gas, and that happens at 100 degrees Celsius. But you may think, well, why is it that puddles disappear, puddles evaporate, but it's not 100 degrees out? And the reason why is because when those particles are just randomly moving around in a puddle, some of them will be close to the air, and some of them have randomly just enough energy to pop up into the air and start floating around and be a gas. So although the temperature of a puddle is determined by the average temperature of all the particles, some particles have more energy than others, and if those particles are found at the top of the puddle, right next to the air, they may have enough energy to sort of bounce off the puddle and disappear into the air. So that's why puddles evaporate, if you were wondering. Alright, so that's it for this video. Tune into the next video, which will be mixtures and pure substances.